Hello then, welcome to a brand new video. This is Hub Beyond Numbers, where we learn maths the easy way. In this video or in this lesson, we are on set notation, cardinality, and then subsets. And by the end of it, you should be able to use set notation and set symbols correctly. You're supposed to find union and then intersection of sets, and then determine the cardinality of a set, and finally identify and count subsets of a set. Let's quickly look into it. So let's first start with the set membership symbols. With the set membership symbols, there are two of them, which we have already considered. So this is just a recap. We have this here, which means it's a member or an element of. And we also have this here, which means it's not an element of. Let's look at these two in practice and then see what they do mean. So considering set E, which are even numbers from 2 to 10, okay, we can say that 2 is an element of set E. You see, 2 is an element. That is where we use the symbol. The same way, we can also say 6 is an element of what? Set E. So all the elements over here that we see, we can say they are elements of the set E. But if you have to take any other number, such as 3, then we say 3 is not an element of set E. You see, 5 is not an element of what? Set E. So this here is how we use these symbols. You get it? So now let's look at another set of symbols. That is the subset symbols. So there are 4 of these subset symbols we'll be looking at. The first one is a proper subset. You see, the proper subset is the normal, what we call subset we know around. Let's consider 2 sets. So for these 2 sets here, I'll call set E the set of even numbers less than 11. Okay. Then for A is the set of even numbers that are prime. We know 2 is a prime number, but it's also an even number. Okay. Now with this, you realize that we can find set A inside set E. You see, the whole of this is inside set E. We say set A is a proper subset of set E. And we write it as A is a subset, right? Or proper subset of set E. That is it. Okay. You can also read it as A is contained in E, because A is contained in E, literally. Okay. Now let's look at this other symbol, which we call the subset, and then can be equal. Now for that, let's take this other set over here, set M, and I'll call set M multiples of 2 less than 11. Multiples of 2 less than 11. Remember I said set E were even numbers less than 11. And then set M is multiples of 2 less than 11. Now, even though these two sets define two different sets, you see, because M is multiples of 2 less than 11, whilst E is even numbers less than 11, you would realize that all of M is in E as well. They are literally having the same set of elements. If you have to compare, you see, they are literally having the same set of elements, you see. And apart from they having the same set of elements, we can also say all of set M is contained in set what? E. They are all contained in it. Meanwhile, they are also equal. You see, they are also equal. So with this, we can say that set M is a subset of set E. And in fact, it is equal to it as well. That is where this sign at the end comes, or at its bottom comes to play. You get it? Then our next symbol is the not a subset. Not a subset. So for the not a subset, let's take the set B over here. It is a set on its own. Now, as B is a set on its own, if you look at it and compare it to E, do we see any of this whole set, do we see it in B? We don't see it in B, not at all. So with this, we can say set B is not a subset. It is written as B not a subset of what? E. Now, this might confuse you a little bit when we say subsets and then element of. But then for element of this one we considered earlier on, then we are talking of just one member. You see, just one member. That's why I use two over here. You see, so just one member being an element of the set. Just one member being an element of the set. But this over here, we are talking of the whole set being the member of another set. Okay, so this is on subset. Then the last one we call superset. This symbol here helps us to reverse the subset. So all it means is, if you are saying A is a subset of E, you see, then we can turn it around and say, okay, then it simply means E is a superset of A. You see, but in the case of this M and E here, this example we gave over here, which they are likely to be equal, that is where we can say what? E is a superset of what? M. So anyways, all we mean is, if you take this subset symbol, this one here, which means that the first one is inside the second one, and if you want to reverse it around and say E is a superset of A, that is what it means. So these are the symbols we use as subsets. The next set of symbols we'll be looking at is for unions and then intersections. For unions and intersections. So talking of union, what it does is it combines all the elements from both sets. So you have two sets and you want to combine all these two sets to form one element, or sorry, one set. We use the union to do that. And we'll be looking at an example shortly. For intersection, what it does is it looks for elements that are common to both sets and then write them out. Okay, so these are these two. Let's look at what they do mean. Now with these two sets here, set A and then set B, if we want to combine these two sets together, we say then we are going to get A union B. You see, and it's going to combine all the elements from both sets, yet without repetition. What do we mean by without repetition? If I want to combine, I have one from set A. So 1, 2, and then 3. Now I want to combine, I want to add set B to it. There is 2, but we have already written 2. You get it? Now there is 3, and we have already written 3. Then the last element in set B we could also add is what? 4. Have we already written 4? No. Then we come and then write it attached to it. So for union, it will combine sets or elements from both sets, but it doesn't repeat. It does not repeat them, so that we don't have to write double 2s and then double 3s, but then we write only one of them. That is what union does. On the other hand, if you want A intersection B, so we look at A and then B, and you realize that there is 3 here, and then there's 3 also over here. You see, also there is 2 here, and then there is also 2 over here. It takes the meaning of the word intersection in English. That is, it is in both of them. You see, so A intersection B, that set is going to be 2 and then 3, because it is 2 and then 3 that are in both A and then B. They are in both what? A and then B. That is it for intersection of set. Now we are looking at one other set symbol we call complement of a set. Complement of a set. Talking of the complement of a set, the complement of a set is what? Is the set of all elements in the universal set that are not in the set we are talking about. Okay, so it has a notation, and this is its notation. So for the name of the set, you write it out. If it is set A, I'll write my set A. Then since it is complement, I put C on top of it. You see? So if it is set E, you write E and then its complement. Okay. Now, if you want to use set builder notation, then remember in our first video we spoke of how to represent sets. So for set builder notation, we say A complement would just be what? All element X. You see, so X is such that X is an element of the universal set. It is inside the universal. So we said the complement of a set is a set of elements inside the universal set. It is inside the universal set, all right, but then it is not in set A. You see, so X is an element of the universal set, but then X is not an element of A. This is how we write it. So this is set notation. That is all there is. What this means is if we have a universal set which has element 1, 2, 3, 4, and then 5. If I take set A to be the even numbers in the set, then that is going to be just 2 and then 4. You see? But if I want the complement of A, then what remains is the set in the universal set, but not in A. You see? So starting from 1 is in the universal set, but is it in A? No, it's not. So that is going to be part of the complement of A. 2 is in the universal set, and then it's also in A as well. It is not a complement of A. You see, 3 is in the universal set, not in A. So 3 is a complement of A. 4 is in A. Then we have 5, which is in A as well. Sorry, which is not in A. So it's a complement of A. So all we are saying is if you take the set A and you remove all of its elements from the universal set, it becomes the complement of A. They are outside of A. They are what? Outside of A. Now, this video has actually been longer than I expected, and yet we have cardinality of sets, and then the number of subsets of a set as well to look at. So I'll pause this session here and continue in another video or lesson. And that would just be the next one on the playlist. I do hope this video was helpful. If there's anything, you can always let me know at the comment section and I'll address that for you. This is Happy Beyond Numbers, where we learn maths the easy way. See you in our next lesson. Bye.